suppose you could say loosely the jet is a stream of air. Yeah, I'd say I still call it a jetpack. It feels like a jetpack, and nah, it's for all purposes. I think it's fair. It's a fair name for it. Okay, since going public, of course, we've been approached by lots of different sort of sectors. Obviously, the engine was extremely sought after. We got there and we had a 60 kg engine capable of 200 horsepower. That's something that's quite cool. People love the idea of putting that into their microlights, and of course the EA air show was full of microlights and ultralights, that kind of thing. So the engine's been very popular, but at this stage, since we're focusing on the jetpacks, that'll be the initial thing, but I can see an engine being a spin-off of this, which will, in its own right, be a very successful company. PR promotions, obviously just doing flights for things like Olympic Games, World Cup matches, things like that. Commercial could be in building inspections, beach rides for tourism, merchandising, computer games. We've also been approached by at least a few movie companies. Obviously we want to put this into movies and things like that. Also advertising for various companies. And search and rescues is also another big one. There's a bit of a market there.
Military?
Military, yes. And military, they've shown some interest as well. Now the thrust, now we're going to a bit of more technical stuff. This is probably stuff a lot of you guys want to know a bit more about too. So basically the thrust is produced by two ducted fans. Okay, they're running at 7,000 RPM. They're spinning in the same direction, which is sort of counters what a lot of people assume. And we get past that by straightening the air as it comes out of the ducts, so it all comes out straight, so you don't end up with any residual swirl, which means that once you've accelerated to flying RPM, the machine doesn't really want to swirl at all. But when you are ramping up or dropping the throttle, it's like it's like being in a hot rod or something where you spin the engine up and the car sort of tilts. The machine does that as well, so you've got to counteract that as you launch off the ground. Okay, the combined 270 kgs of thrust, so your pilots probably range between about 70 kgs and 110 kgs. The machine, our design weight would be 115 kg is our target weight for the machine on its own, and then with safety equipment on top of that. And obviously composite construction, carbon fibres everywhere in this, and Kevlar. Power transmission, it's actually relatively quite simple. You've got the engine driving a drive shaft in the centre. It's driving two tooth belts. Obviously those go into pulleys which you can change the ratios of the machine. And they're driving the two fans the same directions. The engine, we're looking at engines that are on the market. There's nothing really that suited us as far as the weight and the power. So in the end we had to sort of build a custom engine. What it's sort of based on is a motorcycle engine, is a single-cylinder motorcycle engine, and we've gone and effectively sort of used that as a sample on how we could build a four-cylinder V4 version, which, yeah, obviously gives us 200 horsepower, runs very conservatively. Obviously reliability is a very important thing here. So running at 6,000 RPM, which isn't extreme for a two-stroke at all. To give you an idea, prototype engines that were from Rotax, we're able to run them at about 8,200 RPM, and they were screaming. So, and by running those engines, we're running into unreliability issues, and that's one of the reasons we had to go for our own engine, and it's been a great move. This is one of those areas where we had to get external expertise into the company again as well. It's good to start getting in contact with people all around the world. Like in our case, we're in touch with Mercury Marine, and they've advised us on how to make our engine as reliable as possible, like border stroke ratios, that kind of thing, mean piston speeds. Alright, safety. Obviously critical again with this machine. Parachute covers you in high altitude situations. The pogo at the bottom, that expands out below you to protect you as you come down for a heavy landing. The Kevlar hoops within the ducts, they sort of form almost like they stop the ducts from disintegrating, so there'll always be sort of two hoops next to you. So from most situations you're actually covered by the machine, you're sort of semi-cocooned, I suppose you could say. The roll bar at the top is obviously for rolling over. You want to fit the pilot as much as possible. So also use it to attach our radio equipment to it as well. Structure is primarily carbon fibre, once again for lightweight and strength properties. Kevlar, where we need ballistic protection, so around the hoops around the ducts do that function of safety as I mentioned before, but they also stop the blades, if anything like there's a bird strike or something and the blades disintegrated, it would stop the blades from coming out of the ducts. So that's required there. Foam cores, just to separate carbon skins apart to give you a different stiffness. Aluminium, pretty much anywhere you want to use a metal. Steel we avoid like the plague really. We only use that based on the crankshaft and for fasteners. And acetyl plastics and other sort of plastics, we've started to really get into those because they can be extremely useful. They can take the place of bearings if you use them right. Flight controls, this has been a huge thing for this project in the last year or so. Up until, I'll say 2 years ago, the target was thrust. The last year and a half, control became a major issue because we're now finally in the air and able to fly way up into the air, and now we want to be able to fly. So the controls have been added to. Originally, when I first arrived at the company, I was doing some flying back then as well, and we had to fly using weight shift. So you'd almost spin the machine and you'd rock your hip back and forwards to change the weight balance of the machine, and you use your legs to do that as well. And by doing that, you can sort of tilt the machine and try and cancel out pendulums, but that is extremely hard. Yeah, no, it's hard work. So we had to move on by putting these pitch and roll systems down here, where we actually use that to tilt the machine to give us the vectoring thrust, as well as also balance it. So when it goes into a pendulum sort of state, you can cancel that. Now that was heavy load on the pilot as well. The pilot had to toggle the controls constantly. Sort of, I suppose, helicopters you could do the same thing, but it's a lot slower. Being such a small inertia machine, the tilts are very quick. So then we fitted a auto stability system, and that now takes care of all the small fluctuations and around a given attitude, and then you just define where you want to go. So if you actually you can actually do this while you're flying too. You can have the throttle and you're keeping control of that, and you take your left hand off, and what that does is it effectively checks the pitch and roll system, make sure it's functioning. You can give a wave or a thumbs up or whatever, but it'll just sit there quite nicely in the sky until you change it, you tell it where you want it to go. The throttle is like a motorcycle at the moment. It's going to see you're directly linked to RPM. Obviously, so if you drop the throttle, you'll drop the machine and just go straight to full throttle. You're gone. It's a lot of fun trying that, but don't recommend it. Now, just here's another bit of just to see how it controls. So as you can see, they sort of tend to be, you can see those vanes working, definitely working quite hard there. However, the pilot didn't really have to do anything. I think during that flight, the majority of the time I was just giving it some telling it I want to go forwards. And even in the turns, basically it was almost just pulling it back and pushing that, basically pushing and pulling with the right hand basically does the yaw, and of course throttle. And when you are flying and you want to make a turn or something, what you usually find is you'll drop